So I can do A equals input number, B equals A plus 10, print B. So I can write programs like that, okay? And I can make these programs longer and longer and longer, depending on what I'm doing. But pretty quickly, programs become unmanageable if we don't break them up. What did I say was the word beginning with D, which was breaking things down? Excellent. Decomposition. So what we should try and do, what the Craig and Dave programming thing has tried to get you to do, is to think about decomposition right from the start. Okay? So think about all your tasks and break it down into separate packages. And when we're programming, in most languages, there is a system called subprograms or procedures or functions. These allow us to package up our entire program into simple steps that we can then rearrange later on and use again and again and again. So in this case, what I've actually got are 3 parts to my program. So I've got something that asks the user for a number and converts it into a number. I've got something that does a calculation, and then something that outputs the result. Now if I want to edit this and make it jazzier, the output, I've got to make sure I get to the right part of the program and edit that part. Okay, which at the minute isn't too hard because the program's simple. But over time, as this program grows and becomes more featureful, I'm going to be scrolling up and down, and I'm going to have to find the right line, and I could easily mess up something else. So what I'm going to do is I'm going to, from the get-go, break this up into some functions. Python only has functions, which is what you should have come across. And we define a function by saying def. Okay, so I'm going to get a function that is going to give me a number that the user entered. So I'm going to give a name to this function. I'm going to call it getNumber. When I define a function, I put parentheses. And what the parentheses say is, oh, this named thing is actually a procedure to run. And then I put a colon, which is the notation Python uses. You then have to do this indent. This is where Python starts going horribly wrong, because it breaks the indents and it goes, it's not indented to the same level and everything. Right, so what I'm going to do is I am going to create this so that it does the conversion for me, generates a number and gives me a number. And then whenever I want to use get a number, I don't have to write all this, because this is hideous, where I have to put int around input. I'll just say get number. But I'm also going to specify a message. So I'm going to say message. Oops. So what I've done there is I've said, right, when you use this, pass me a piece of data that I'm going to call message. I refer to it as message. So what it's going to do internally, so this is all internal, I'm going to do this. So it's going to look like the same code to start with. I nearly put a semicolon there because I do have too much C#. Do that a lot. Right. So I've created this function that accepts a value that it displays on the screen to the user. It gets a number back, and that's what its name is, so it's named sensibly, and then it returns it. So it collects the information for me and then returns it and gives it to me. So instead of me writing this in my main code, I can write this. Let me just close that window. Right, instead of me writing all that, which looks complicated and I could easily screw up, I can just say get number, enter first number. Right, it doesn't affect that code at the top, because that code is going to say whatever was passed in these parentheses, I'm going to refer to as message. It's called a parameter. Okay? And then my code that I've written in the main part of my program reads a little bit more sensible. Because I say A equals get number. I know I'm getting a number. I don't need to know how that number is got. If I want to get that number a better way, so that the user can't like crash the program, I don't edit this code, I edit this code. So if I was to then go B equals get number, and I say enter certain number, I don't need to say mate again because I've already said it. So what that enables me to do is take away from the main logic of my code the complicated, detailed information about how we get a number from the keyboard. Someone else could have written this function for me. And so I know what I want to do, but I don't know how to get input from the keyboard. Someone could write that function for me. Okay? And now I've written it once, I can use it multiple times. And I don't have to keep doing the int bit and the input bit. It's done once. So if I edit how I do my input, I've only got to change that code once there. Doesn't affect any of this other logic. The printing code. I mean, I'll change the thing now. C equals A plus B. The printing code, I could do a similar thing. So instead of just like printing out a value, I'm going to create a function instead. Notice I'm putting them at the top. What I'm doing is all the like little modules that I'm making, Peru, all the modules I'm making, I'm creating them at the top so I can see them before I try and use them. Okay? Some languages you have to do that, other languages it doesn't matter where you put them in your code. It depends, it's a language specific thing. I think Python throws a hissy fit if it hasn't seen something before you try and use it. Right, so I'm going to put something in here and it's just going to print C. But if I do that, can anyone see a problem with that? So I'm just going to say down here, display output. What's going to happen whenever I run display output? One of the things you've got to get used to is like looking at a piece of code and working out what it's doing. So when it gets to this line, I'm basically saying call the function display output. What's display output going to do every single time? Yeah.
So if you have more than like numbers after C, it's only going to print that number C. It won't print.
Yeah. It can only print C. That's it. Okay. So in this case, what I'm actually going to do is I'm going to pass the variable C, the value of it. But I need to be able to refer to that, so I'm going to call it output value. So even though down here I've said display output C, when the routine runs, it goes, oh, whatever you gave me, I'm calling it output value. You don't need to know I've called it output value, but that's what I'm going to refer to it as. So these parameters are decided by the person who writes the function. It does not affect me. I could actually put 12 in there and it will display 12. If I give it A, it will display A. If I give it B, it will display B. If I give it C, it will display C. Okay, so I might want to pretty this up a little bit. So I might print, and I might do something like this, and I might put some like funny bits of text before and after my answer. But the main block of my code now looks like this. So the logic of what I'm doing is clear. How the input and output works is an issue that I don't want to worry about when I'm looking at the logic of my code. So when I'm breaking down my problems, Peru, when I'm breaking down my problems, what I'm trying to do is I'm trying to simplify everything. And what you can see about these two things, so instead of them doing multiple jobs, they do one job. So this one is solely responsible for getting that input for me and turning it into a number. This one is just nicely formatting me our answer. It just prints out a value for me, but it prints it out in a nice way. What that value is up to the person who did this logic. So you could argue that this should be in a subroutine. So I could actually create another subroutine here, call it main, and then I could put all these lines of code in it. I need to indent them though. And then actually I've got a program that doesn't do anything. It's got 3 blocks of code that are all in function. So if I tried to run this, that's the output, nothing. But if I tell it to run main, so we call this a few things. We call it running, we call it calling, we call a function. We say, do the function main. So if I run that again, oh, and there it goes. It's saying to me, enter first number, mate. So down here I'm going to type 56. Enter second number, 10. Answer was 66. So it's done that nice prettified writing. But it isn't messing up the logic of my code. So my code is some input. My logic is a calculation and then some output. The fact that those 2 bits of code are more complicated than that, that's hidden from the main logic. What we're trying to do, wherever we're coding, is we're trying to simplify. The simpler a bit of code is, the less things that can go wrong. What can go wrong here? I might forget to do the int bit, and then I won't have a number. And then when I do my calculation, it'll screw up and say, oh, it's not a number. But that's the only thing that can screw up. I don't have to hunt. So if I get a fault, so let me do this. Let me get rid of that and see what happens when I run it. Hopefully I'll get an error. Oh, hang on. If I go to the output window. That was that thing that we had the other week. Do you remember when we had numbers but there were strings, and when we did plus, it just stuck them together. So it said 12, 13. And you go, hang on a minute, that's not right. So you might think, oh, hang on a minute, it's going to be a problem with my calculation. But actually, we can look at the input thing. It's because we're not doing a number. Now, when we had that fault, remember we had 5 numbers when we did it last week, the average program. So we had 5 numbers. We had to put input in, input in, input in, input in 5 times, didn't we? And if you'd have forgot one of them, that'd have broke it completely. Now, if we'd have written this code like this last week, that would have simplified the logic of our program completely. We'd have written that bit of code once. You're trying to minimize repetition. So whenever you're doing any code, if you seem to be doing a similar thing over and over again, your brain should be going, you know what, is there a function there that I could use? And that's what I should be doing. Okay? So the key things are create your functions, give them a meaningful name. If you need to pass any data to the function for it to use or do its job, that's what these parameters are, these bits. Okay? We can call them whatever we want, because we just use it to refer to something. Now this adding bit, I could make a function out of that. So I could create a function, do calc, and I'm going to get it to give me 2 numbers, num1 and num2. And what it's going to do, it's going to calculate an answer. So I'm going to do the add one. So I'm going to say num1 plus num2. And then I'm going to return that answer. Oops. If I press enter, I'm going to return that answer. So I can say, instead of A plus B, I can say do calc with A and B. But if in the future I wanted to do A and 10, I can do. Doesn't change my calculation code. I'm just changing the data I'm working with. So we want things to be flexible. It's what we call data-driven design. So we're trying to like minimize hard coding everything, because that leads to like dead ends. A lot of the little tasks you'll do, you probably could say, oh, we don't need to do this. And you'll see, if you ever look at any Python tutorials, that people do massive long programs. And like say, look, let's code this in 2 minutes. Snake in 2 minutes. And they've got this massive long program that they've copy-pasted, and it's like you're asking for millions of errors. If you try and follow it along, you go, it's broken. It's broken. I don't know where it's broken. I don't know what bit's broken. But with this, at least you've got a chance. So I've broken this down. So let's just verify that that runs. So I'm adding up my two numbers. I'm going to pick numbers that I know. So I'm going to have 10. Oh, I've done it again. I don't know why I don't automatically put the cursor down there. But it doesn't. 10 and 30, which should be 40. Hey, 40. If I want to change the calculation, I don't have to alter this. I just alter it here. Okay, so if I want to do divide, my logic of my code is get my input, do my calculation, display my output. Input, process, output. The standard format of every single piece of code you'll ever write. So again, I'm going to do 10 and 30, and then I get that hideous number, 0.33333333. Why do I get 0.3333333333? Can't represent it exactly. It's not an integer, so as soon as you start dividing, you end up with this problem. This is our float problem, yeah.
You know it's 0.333. Can't you just do like 0.3 in the reoccurrence and then just instead? So it's going to be everlasting.
It is going to be everlasting, but that's physically how it's put it in. But yes, we can do that. We can round it off. But now that we've written our code like this, we can do that without altering the logic. So let's do it in our output. Let's round it off. I can't remember how you do that in Python. Let's see if it's round. Might be the round. Might not be round. Might be math.round. Right. I've now come across something that I can't remember how to do in Python. What do you think I do? Right. I go onto Chrome, because the Google one's better than Edge. But Bing is just not a very good search engine. Right, so if I do this, I say Python round value. The round function. Oh, it is round. Right, so I have two parameters. So this is a function someone else has written for me. I could do round myself, but it's actually quite a complicated process. Okay? So I'm going to use someone else's function. So it's got two parts, the number I want to round and how many decimal places. Right, okay, so I've looked that up, so I'm going to do that. So I'm going to say, was it capital R? No, little r. Round. The number I want is output value, whatever I was given, and I want it to, what should we round it to, 2 or 3? 2. 2 decimal places. Now, we have got brackets inside brackets and things, because we're saying print whatever this is. Doesn't affect this code down here. This code is still nice, simple, structured. So let's run that and see what it does. With 10 and 30 again. So I'll put 10 in. So 10, 30, 0.33. So by using the modules, the functions, I'm simplifying my code. I wanted to change that. I only had to change it in the output code. Didn't affect anything else. That's the problem with floating point numbers. Let me just write another little program. So I'm going to write another function just to show you this problem with numbers. I'm going to call it funny thing. Yeah. It's just going to do a little job. A equals 0.1. And then I'm going to do a loop. And I'm going to do a stupid loop. Anyone know what that'll do? Slightly more than once, yeah. What's a number that is definitely more than once? That begins with I. Infinity. Right, so what I'm going to do is I'm going to print A out, and then I'm going to add 0.1 to A. And again, I've written a little function. So instead of running my little main program, I'm going to comment that out. So I'm not deleting code, yep.
Do conditionals only work with while loops?
Well, it depends. In Python, you can do other forms of loop. You can do like for loops, but you can do sort of conditions on those. For loops, the loops are weird in Python. Okay, while's the flexible one. Right, so I haven't deleted any code. I've still got this there. All I've done is I've commented out the line that called the function. So I want to run this one now. So if you was to do this as one long program, you'd have had to comment all those lines out. And it's like, well, I don't have to do that. Right, so I'm going to call funny thing. Let's watch the output from this. Now, can I pause this? I probably can.
I don't think you can.
I'm
not sure.
I think you can.
Stop the volume.
Hang on.
I like funny.
So what's the largest number in standard form?
Oh, it doesn't matter. I'll go away now.
Sir,
Yes?
what's the largest number recorded in standard form?
So can you just close down the time?
Yeah, I think that's stopped. I can't get rid of this bloody thing now. Right.
Might want to pull up the terminal.
I know. There it is.
Make sure.
Oh no.
Keep going.
So if you press the three dots, then then I think it's like end solution.
No, it's not there. Oh, up here, you mean? I can't remember. I've never bothered writing a purposeful infinite loop. Right.
I think if you press
I'll trash binned it all. Right. Okay, so let me do it without an infinite loop this time. So I'll just stop it after a few. I just want to. Oh, what is it doing there? I think I've just totally cacked up Visual Studio Code. I have.
just drag the terminal down.
We made an infinite loop. It's Visual Studio Code.
I have. Right. What was funny? The reason that happened while terminal was on, that program every time around that loop, what it was doing is it was having to print to the screen. So it was having to communicate with Windows to do that via Visual Studio Code. Okay. As soon as I killed the terminal, it went, aha, I don't have to print anymore, so I can now go at super speed, which completely tied up. There is, in Windows, there is a thing called the event loop, which is how you interact with the programs. Okay, so it's got time to respond to updates and things like that. But what happened, because that infinite loop was running, it never allowed the event loop to happen, which is why Windows then kicked in and went, this program's been real bad. I don't know what's going on, but I think you need me to kill it for you, don't you? That's why it pops that message up. When a program's doing something where the user can't interact with it anymore, Windows will kick in. Didn't used to do that. If I'd have written that program when I was doing A-level computer science, if I'd have done that on a computer that I was using, that was it. I'd have had to turn the whole machine off and lost everything. But actually, what's actually quite cool here is Visual Studio Code has still got all my code. Even though I didn't save it, it's kept it. So I am actually going to save that Should have saved it. Yeah.
Is that what happens with the override systems?
What you can, if you can try and crash, that wasn't crashing the operating system. The operating system was doing its job. But yeah, if you can try and like trip the operating system up, and then you can trip the operating system up when it's in supervisor mode, which is where you can run scripts that do everything. That's what all hacks are trying to do. All hacks are trying to like get into hypervisor state, and they can get access to the computer. Right, okay, so I'm going to just change this. So instead of doing an infinite loop, what I'm going to do is I'm going to do a count. So I'm going to say b equals 20. And I'm going to say while b is greater than 0. And in my loop, I'm going to say b equals b minus 1. Okay, and I'm going to run this now. So this should happen 20 times, he says. Syntax error. Right, what is a syntax error? You should get this all the time when you're programming. What does it mean? It's a specific type of problem. What does syntax mean? Right. Okay, you picked up spelling. Spelling is one form of syntax error. Syntax is a similar word to grammar. So if you made a grammar mistake in English, what would that mean? Or in French or German or whatever. What do you mean by grammar mistake?
Wouldn't make sense.
Right. Wouldn't make sense. You're not following the rule, are you? So a simple thing in English, gents, listen. A simple thing in English is a sentence starts with a capital letter, ends with a full stop. Yeah? One of the basic things we teach you before we get into all like the nouns and verbs and all that rubbish. In programming, it's the same thing. So when we have a syntax error and it says invalid syntax, I have not followed the rules of Python. And it's telling me what line's wrong. Yeah? Go on.
What about index errors?
Oh, I don't know.
Index errors is when we're accessing lists and arrays. Right. It's trying to help me, and it's saying, right, this is rubbish. It doesn't, Python's funny for this. Most of the languages will be able to give you a hint as to what's wrong. This one's saying no quick fixes. Right, I shouldn't have put a colon there. That's the problem. It should have just been b equals 20. Now, if I run that again, hopefully it'll run this time. Right, okay, so let's have a look at the output in the terminal, because it's interesting. I started off with 0.1, then I added 0.1, and I got 0.2, which is what we'd expect. Then I added 0.1 again, and I got 0.3, 0.4. Then I added 0.1 again, and I got 0.4. And it was stable again, and then we got to 0.7, we added 0.1, and it went 0.799999, which is not 0.8. And then we dragged that through, then it sort of settled itself. What's going on? Yeah, we cannot represent some numbers exactly. We use float. You know, we talked about the different types of numbers. Float is for real numbers with fractions. Go to bed early. Right, this is what we call a rounding error. And you have to be very careful when you're dealing with numbers with fractions. Yes. You have to be very careful. So if we was to write our code, so I could have written this and I could have said, keep going until A is 1.5. But in the console, which I've now closed again. Oh, yeah, it was there. Oh, just show me the terminal. Control that. In the console, I wouldn't have got 1.5. Because when I added it up, it was 1.5000002. So that is something we have got to be careful of in the future. Right, okay, I'm going to stop that recording next. That was just like a little bit of an intro to some things, and particularly the functions. Right, the program I want you to have a go at writing, and I want you to break it into functions.